Hello, Mark Biasotti with SolidWorks. Last week I had the pleasure of presenting at the New Hampshire SolidWorks Users Group hosted by Rapid Sheet Metal, and I had promised the group to post files and presentation for them so that they could follow up on what they've learned about these tips and tricks. I realized that since it was a live demonstration of SolidWorks and essentially the model files would be hard to actually try to reproduce the tips and tricks, so I thought I would provide this video along with the files. That way that anybody who would want to review what I presented would be easy for them to be able to reproduce the tip or trick. So I picked my favorite 14 only because I have an hour to present. Obviously I had many more, and I just picked a general selection of the ones that I thought are my favorite and the best for saving time and being efficient when using SolidWorks. So we just have 14, and this presentation will be under an hour. Maybe I'll do a follow-up for part 2 of tips and tricks and present 14 additional ones. But at this time, these are the 14. So without further ado, let's just get to them. Let's start with the repeat command. Now this is a feature that is often underutilized in SolidWorks, probably because we do such a good job of being able to stay focused on being able to apply a feature to multiple instances on your model. There are some cases though where you can't. One of them that I can think of is our full round. Our full round can only be, you can only apply one full round to one face set at this time. So to demonstrate the repeat command, let's just go ahead and apply a full round to these 3 faces, and you can see we get our full round. Now if we go ahead and accept that and then immediately hit the enter key, you get back to the previous command in its previous option state. So this is great for full round since we have to apply it 4 places on this model. We're just going to do that and then keep hitting the enter key to continue with our full round. Now a quicker way to apply a full round that you might not be aware of is to click your first face and then immediately click on your right mouse button, and that'll change the focus to your second selection or selection set. If you click again immediately on your right mouse button, it changes to the 3rd set, and in this case if I don't want to rotate my model, I can actually select through, pick that 3rd face, and then enter, and do that all without rotating my view or going over to my orientation view menu to do that. So that's the repeat command. So something to constantly keep in mind when you have to apply many of the same type of features to your model. To be able to use that is a great utility. Okay, so let's go back to our presentation, and let's next talk about the search bar in the feature manager. This is one of my favorites because it allows you to be able to go in and filter on certain parts of your model that you couldn't otherwise. So we have this model here that is a design I've been working on, but you can see there's many kind of not arbitrary, but many different planes in the model that really make it cluttered when coming to work on a specific part of it. And how many times have you been in the situation where there's just one plane that you need? Let's say we'll just pick something like plane 19 here, but we just want to, or maybe even a worse area here, we want plane 29, but all these other planes want to be hidden. Well, you know that under our view command we have the ability to hide all planes, but you lose the visualization for that one plane that you want. So what do you do in a situation like that? Well, I would think a great way to be able to hide all those planes except for the one would be to use the search bar in the Feature Manager. And if you type in plane, it filters it down just to the planes in your model. And you go ahead and you select that one plane, which is plane 29. And to quickly hide all the rest, you go ahead and I'm holding down my Shift key, and I select front plane and then the last plane in the list, and then deselect plane 29, right-click on the rest of them, and say hide. So now I have my visualization filtered down just to plane 29, and everything else is hidden. And that's a great way to use the search bar in the Feature Manager to do that. You can do it also on other things too, you know, like Sketch, if you wanted to just see where all your sketches are, or a specific feature. Maybe I have I have an axis in here. Well, there's two axes that I've created, so that's a great way to filter down to find things quickly, and that's the search bar in the Feature Manager. Okay, so going on, we're going to then talk about quickly creating an offset reference plane. I'm sure many of you know about this feature, but it's good to remind you of it again. Because we build so much of our model using reference planes that the user creates, it's great to have the utility to be able to quickly create an offset plane, which is one of the most used ones. The way you do that without going to reference geometry plane is to click on a plane and then hold down your control key and then drag up. And you'll be able to create it quickly with that offset distance. And then as you pull it away, you can enter a more precise distance. You can also, when it comes time to do lofting, for instance, you can create multiples and create all your loft planes right there using multiple instances of it. So that's the offset, quickly creating an offset plane. Okay, so what do we have next here? Well, the next thing, this is one of my favorites, is repairing and dangling dimensions. So a mantra that I often espouse about SolidWorks is it's the kind of modeler where you trash nothing, you modify everything. And that is true for most things in SolidWorks, not everything, but most things. And it's also true for when it comes down to the sketch level and dimensioning. So let me demonstrate that. I've created a situation here where I've created a dangling by reversing, I believe, one of these bosses. I've changed their end conditions and flipped them around. Well, unfortunately, I made another cut based on those end conditions, and so now I get some dangling dimensions here, as you can see in the olive gray. So let's go into that feature, sketch, and let's take a look at what we have here. Well, it's obvious to me what happened in this old position here was where my end condition for the boss used to be, and now it's out here. So you'd be tempted to just delete the dimension and redimension it, and that's what often most of our users do. They don't realize that you can do it much quicker by just clicking on the dimension and then dragging the red end of the leader to your new reference, and thereby re-referencing and repairing your dangling dimension quickly. You can do it the same for this one out over here. And now in this situation, I've reattached, but actually it's on the wrong side of that reference. And also keep in mind in SolidWorks that you can enter a negative value for your dimension. So let's go ahead and just double click that, and then in your dimension dialog box you could just enter a minus sign and then the proper dimension, which I knew was 5/1000ths of an inch. And now I've flipped it and given it the correct value. I can do the same for this, and then minus 0.005. And now I've repaired my dimension without deleting anything. And that's a great value for reattaching dangling dimensions. Okay. So as we go forward, we're going to talk again about dimensioning. And this time, more about driven and driving dimensions. So this is one of my favorite things to do, is to build sketch blocks. And here I have this 4-bar linkage that I've created using a number of sketches. Oftentimes I'll use blocks. This one was simple enough that I could just use geometry. I dimension all the geometry, and then it drives the sketch. So if I actually just move this, you can see how my 4-bar works. If I zoom out a little bit more and then move my dimension here at the bottom, you can see how the 4-bar is keeping that second section fairly horizontal. So the problem, though, with this is when I want to change my design, because everything is driven or driving, it's difficult to change things, especially when I want my design intent a specific way. So in this case here, I really, with 60 degrees here, I want this dimension to be 60. And if I double click it, I can't do that because it's a driven dimension. So just know that if you right click on that, down at the bottom of your menu, you get the ability to make it driving. Now, you can get to it here. Now, because of my recording, you can't see that dimension. Just know that you can also go to Other over in your Property Manager, and you can, here's the option to be driven or driving. So I'm just going to uncheck that, and of course everything over constrains, because now you have a conflict in 2 driving dimensions. If I click on this one, though, I can make it driven, and thereby I've transferred the driving aspect to this dimension here. Excuse me. Now the reason I want to do that is now I want to change this to 60. And you notice that dimension that used to be a driving dimension is updated to follow that. So now I have my correct change of design intent. I just simply go to this dimension again in my Property Manager, make it driven, and then go to this one and make it driving. So now I have changed my design intent, but without deleting any dimensions, I simply just change the state of the dimension from driven to driving to be able to make those changes. And so that's really handy to be able to do that, especially with sketch blocks and mechanisms. Okay, so we're going to talk next about another of my favorite, which is the thumbwheel control. And we probably should have done that with one of those previous parts. So let me go and find that again. Let's just go back to this one and load it up again. And sorry, I have a little registration issue here. And let's go back in and edit that. And so if you've noticed when you edit dimensions, you get this dialog with this funny looking thing underneath. You might not realize that, or you might realize that's a thumbwheel. And it gives you the ability to dynamically move or change dimensional values, angle and dimensional values, as well as feature dimensions. So if you simply just click the wheel and move it, you can change the value of that dimension. You can also undo that using your Control Z. Let's go in and edit that sketch. And so let's do it with this dimension here. Now, if you have Real View on, sometimes it is difficult to get to that. So I'm going to turn that off. Click on this, and you'll notice when I change the wheel, it will update the dimension. Now in this case, because my sketch is so driven that just the value that I've entered just over constrains it. So this highlights a feature of the thumbwheel that's pretty important, and that is the ability to change the velocity of the wheel. So if I hold down my Alt key while I scroll the wheel, I actually can get 1/4 the spin value that's set in my system options, and that's what I'm doing right here, is that I'm actually just holding down my Alt key while I spin the dial, and thereby I can get a finer increment for my thumb wheel. Now, holding down the Control key will give me, I think, 4 times that value. Let's do it with the dimension here. Let's hold down the Alt key, and the Alt key here is doing it off of just, I believe, 5 degree increments. If I hold down my Control key, then I get much larger increment of control. So just know that you have that capability. If we go with a dimension out here that isn't so dependent on it, here we're just moving the thumb wheel, and you can see that just moving it in its spin increment is drastically changing the sketch. If I hold down my Alt key, then I get a much finer resolution of that. And if I hold down my Control key, I get, well, much larger increments, which in this case of my sketch over constrains it. So just know about those modifiers for the thumb wheel. They're very handy. Okay, going back to our presentation, we'll move on to move, replace, delete face, which is one of my favorites, and really I look at it as a modeling command more than repair, although I use it in repair also. So let's take let's take 2 parts here and use them as examples for delete and replace face. So here I have this switch cap where I have somewhat of a dome shape. I've extruded this, and then I've created this cap on the end. And let me show you how I did that so quickly. I mean, in this case here, you could just simply revolve a profile and get that. What if you had an instance where it really wasn't a revolve that could create and fill this material? We'd have to come up with another method, and I often find in these situations that replace face works rather well. So let's go ahead and create a sketch. I'm simply just going to do a convert entity on this edge, create a axis of rotation, and then instead of trying to fill this material in with solid, I'm going to create a revolve surface. And let's do it just for about 45 degrees in the opposite direction. And now we have a general surface there that we're going to do a replace face, this one for that one. Before I do that though, if I turn back on my Instant 3D, I can make some adjustments here to my sketch. I think what I'll do though is let's create a dimension to drive that, then demonstrate how to do that using Instant 3D. Let's see, why is that driving? I'm not sure, so let's redimension that. How about we go to this point to here? There we go. And now we have a dimension there that we can use to drive that radius. So if we simply click here and then use our thumb wheel, let's do that one more time. And I think just to demonstrate this, I'll turn on Instant 3D. And let's see if we can do this. So if we pull this dimension, and using Instant 3D, we can get that edge closer to where we want it to be, like right about there. Okay, now that we have that surface set up, we can then use replace. So replace face is found under the insert face category, replace face. I have it on my shortcut key, my S key, as a shortcut. So I'm just going to click on my S key, and I have it right here. And I'm going to pick the face that is the replacement surface, and then pick the face that I want to be replaced. I'm going to select through that surface, select other, this face, and so now this surface is going to replace this bottom face. And if I just hide this, you can see that it's done a nice job of that. What's great about the replace face command. It's a very inexpensive feature. I mean, it basically will generally change geometry but not topology, and thereby it's a very quick command in SolidWorks to do. Let's take another part over here and demonstrate a little bit more of replace face. Let's hide this body so it's just not in the way, and then talk about this a little bit more. So in this instance here, the designer has created a parting line, but there are some problems with it. It needs to be cleaned up a bit. It's not quite what I need. So in this case, I just want to have this face continue and just run out into this face. So this is a good candidate for delete face. I'm going to hit my S key and use my delete face, pick this face, and in the default, it defaults on delete and patch, which means it'll take the face and try to remove it from the model by extending adjacent faces. So if we do that, you can see it's done a nice job in giving me the design intent I want with that parting line. Let's go to this part of the model and take a look at it. Here's a face that I really don't need in my model, so I'm going to again click on my delete face and try to remove that by patching it, and it was able to do that. And then lastly here I have this sliver that was created by this parting line but really didn't run out all the way to the end. I want this parting line gap to run all the way to the end of the part. So I'm going to be a little clever here. I'm going to use replace face again by quickly creating a reference surface by 0, which is the way we do copy surfaces in SolidWorks. And then with that selected, I'm going to go right to my replace face, and you can see that it's pre-selected my surface as the replacement surface, and then I can just simply pick this face and OK, and now hide that. And you can see using replace face, it's given me a nice solution for correcting that end of the parting line. Okay, moving on. We're going to talk now about 3D Sketch Extrude. This is not very well known, and it can be very handy for creating complex modeling that doesn't require surfacing, in a sense. So here I have this handle of this tire pressure gauge controller, and it's an overmold. And let's say, for instance, hypothetically, the designer needs to actually create recesses for these rubberized or cold molded areas of the part. So we need to create a pocket for each of these. So let's go ahead and use what we already know about delete face. We need to get these removed from the model and then create a pocket. So to do that, I'm going to go to my right view and then start using delete face for all of these. Now, I could pick all these individually, and that'd be quite a good amount of work to do, but I'm going to again use some of the shortcuts we have built into SolidWorks for just quickly removing those and selecting. So if I go to my wireframe view and I use my filters down here, I'm going to set it to face filter, and then I'm going to pre-select all of those faces, then S key to delete face, and click OK. I was able to very quickly pick all of those faces and remove them from the model. So if we go back to our shaded view, you can see they're completely gone. So, but we need a reference for one of those. So let's just roll forward before we did our delete face, and let's just pick that one, and we're going to create a 3D sketch. Now, in a 3D sketch, if you use the convert entities and pick those, I can actually make a 3D sketch which is an edge that's directly copied from the 3D model. Again, instead of picking all of them individually, if I pick one and then right-click and say Select Tangency, it gives me that selection very quickly. And now I can just go to Convert Entities And while I'm here, well, let's just roll forward. Now we have the basis for actually using this 3D sketch to extrude into the model. And you can do that in SolidWorks with 3D sketches. Before I do that, though, I really actually need a direction. That's one additional piece of information that extruding a 3D sketch needs, because 2D sketches know their direction based on the plane they're drawn on. 3D sketch doesn't have necessarily a sketch plane that it's built on. So in order to take care of that, I'm going to go on my right plane. I'm going to create just a very simple sketch that's kind of normal to at that point of the surface, and build some really simple vector or path for for that 3D sketch. So let's just make that and that perpendicular, and just make this construction. So now I have everything I need to actually extrude that 3D sketch. And so if I pre-select that and go to Features, Extrude, Cut, and then right below the type of direction I'm doing, I have this arrow, which means direction of extrusion. I'm going to pick this piece of geometry here, turn off your filter, and now you get a preview of that cut of the 3D sketch. And what it's doing is it's extruding that 3D sketch and capping it at each end. So because this is a complex algorithmic surface, I want to make sure I remove the material on this opposite side. So to do that, I'm just going to simply go second direction by a certain distance, and know that I'm actually cutting through both materials. So let's just make these values just a little bit smaller. Actually, let's make that one what it is, and then our cut will be a little bit shallower. So I'm going to say 03, and let's see if we can do that. So it's calculating the cut, and it's cutting through two bodies here because I have both my overmold and my understructure. And you can see now that it's cutting a pocket very shallow into that. You can actually add draft to that extruded cut wherever you want. Maybe a better way to demonstrate it quickly is also to create a spline on surface. And here I'm going to create a spline which essentially is just holding to the surface. And with that, now I can cut. Now while I'm here, I'm just going to create a little reference point in the middle, and then again create a vector for that cut. To do that, I can use that point to create an axis that's normal by picking this sketch point and this surface, and there I have my axis. So I need to view my axes. And now I'll go ahead and maybe I'll just, at this point, I'll just extrude this material using this sketch, using this direction, going the opposite way. And now I can just create some material here. And you can see that it's offsetted that surface, extruded it and capped it using this direction. So that's really pretty handy without it having to get into surfacing and creating that via boundary or loft or something else. Okay. So we've talked about 3D sketch extrude. Let's go to using connectors and boundary. So if we bring up this file, this is probably something that Rapid Sheet Metal has done before, where we want to create a duct. And so we're going to use our boundary boss, simply just pick these two profiles and create that object. And if we want, we can actually just make both the beginning and end profiles normal to the profile. And we have that duct going from a round to a square opening. And then we can actually use lofted sheet metal blend to do that. So if we look to the front though, and this is the question I often get, is if we turn on our edge view, you notice that we don't have symmetry here, in that this transition from the rectangle to the circle is not symmetrical with the other side, and you can see there's a kind of twisted. So the way to overcome that is to use connectors. So if we go into this model and look at it, you can see in this sketch here, actually I should probably roll back to that and show you, that if you look at the sketch, I've created some sketch points here that are coincident to the circle and coincident to the rectangle's construction lines to make them symmetrically placed around the circle. So if we go back to our loft and edit it, we can now use these points, these sketch points, to snap our initial connector to, but then we can add 3 more to make it perfectly symmetrical. So the way you do that is right-click on one of the profiles, add connector, position it, and then keep doing that. So maybe I'll just go ahead and add 2 more and then I'll position. So if I add my 4th connector, now it's just a matter of making sure that I get them positioned correctly. You can also turn off your preview to make that a little easier, more clear. Also maybe want to turn off my planes. And then just snap these. When they turn black, you know they're snapped. And there I think we have it. So if we go and look at our front view, you can see we have complete symmetry for our loft or our boundary. Okay, now another question I get asked is, yeah, that looks good, but I don't like this crease line that is occurring in the model. I want it to kind of slowly, I want it to be smooth when it gets to the circle, and you can see that it's creased almost all the way up to the circle. So how do I take care of that? Well, insert into your feature, which, as you know, if you want to actually unabsorb the sketches temporarily, you can do that. That's what you're doing here. Then roll just before the feature, and now you have your sketches that are being used currently by your boundary. The reason I'm doing that is that I want to actually create another profile of this circle that's just inbound of this. So I'm going to use my offset plane command, holding down my control key, dragging out a plane, and then I'm going to just, I think I want this exactly to be the same as this, so I'm just going to use this sketch and this plane to create a derived sketch in this position. And so now when I go back, roll forward to my boundary feature, I can edit it, and then I can include this, this sketch. Now, I'm going to warn you here, because we've created boundaries, or I'm sorry, connectors, then it's user-created connectors. It really kind of gets screwed up in its twist order. So really the best thing to do here, I'll just be frank with you, is just reselect your profiles. So I'm going to clear all of them, and by doing that you're going to give it the proper order of how it should loft. So with that, of course, you have to reconnect all of your connectors, and we could do that, but I just won't take the time to do that. But you can see that if we apply our normals again to our beginning and end, and then complete, you can see we get a very nice transition. And the further you move that reference plane back, the more smooth you get towards the end of the circle, and that's how you can do that. Okay, so let's go back to our presentation. And let's talk about orienting normal to view. There sometimes, because we do so much sketching in SolidWorks, and sometimes we get objects that when we enter into our sketch plane to do a profile, it doesn't orient it correctly. And here's the situation here where if I click on this front of the model and create a sketch and go normal to, I want this chamfered surface to be up. So I just need you to know that you do have the ability to do this. If you click this face and then this face, then go to your normal 2, the last face that you pick actually is the up face. And that's how you get the orientation of your sketch plane to the way you want it. So now if I start sketching, you can see that if I place this line, I would maybe be tempted to immediately just make it vertical. Well, it's not vertical because remember you rotated your sketch plane. So how do you get around that? What if I want this to actually be my vertical in my current position? Well, again, you have a way out of that too. So if you go to your tools, sketch tools, and go down to modify, modify allows you to actually rotate your sketch. So if I rotate this sketch 60 degrees, went the wrong way, so let's just say minus 120. Now we've got a situation where I've modified that sketch and now I get the correct orientation. I can continue to sketch and you know, have it behave the way that I want it to, and you can see it's automatically applied a horizontal constraint there. So that's how you do that when you're using the sketch normal 2. Okay. So let's talk about intersection curve, another one of my favorites. Here we have a model where we have this area that's going to be a fill feature, but in order for it to be the way I want it, I need to create some bridge curves. So bridge curves are basically splines, 2D or 3D, that bridge from one surface to the other to redirect or to modify the flow of its surface. So in this case, I can create a 3D sketch, and I can create a 2-point bridge curve or spline. And then I can assign, if I go to my right view, kind of move my vectors for each of these, like so. I can actually make a tangent relationship to this face and continue to just move this curve along the edge. To do that, if you click on the spline itself, hold down your control key, pick the edge, and then the surface, you get either tangent or curvature. I'm going to pick tangent. And now if you go into my right view, you notice that as I slide this, it's going to stay tangent to that original vector, but always tangent to the adjacent face. You can't really see that, but trust me, that's what's going on. Okay, so that's a 3D sketch. Let's say really 3D sketch is not the right thing to do here, but 2D sketch right through this plane is really what I want. So I want to create a 2D sketch spline and then introduce this intersection curve idea. So I can create a 2D spline from here to here, but really I have no reference for it to be able to make it tangent to the adjacent faces because you're in a 2D sketch. So a great utility to have is the intersection curve. And if I hit my S key, I have it on my S key menu, click intersection curve, and intersection curve intersects any two faces or a face and a plane and creates a constrained curve at the intersection. Because we're in a 2D sketch, it knows that the plane is the first face. And then if I simply pick these adjacent faces that intersect the sketch plane and then say OK, I get these intersection curves, which are going to be very handy for my bridge curve. So if I pick both of them, I usually just go immediately and make them construction because that's all they're going to be is helpers. And then I can create my spline and then make my curvature relationship to both of those. And there you have it. So it's a great way to use that intersection curve to create bridge curves in 2D like this. Just to show you what I've done with those, if we roll forward to that actual fill feature and look at it, here's the fill feature, and if I edit into it, you can see I've used two curves like what I just demonstrated to show that. If I turn off my mesh, you can see them better there. So there are my two curves that I'm using as constraint curves, and that's exactly how I built them. 3D one, and then, well, they're both 3D, to help that fill feature to be the shape that I want it to be. Okay. Okay, so I know you want SolidWorks to be fast and efficient, and we've built in a lot of tools to help you to do that. Let's just talk about simple filleting and how you can use hidden edges to do that. If we go and want to create a fillet feature, just a constant fillet on this edge by, let's say, 1.5 millimeters, we can do that for a lot of our model, but then, you know what we do, we have to rotate our model around to get to these back edges. Well, you don't have to rotate the model view to do that, because if you have select through on, you can actually just grab the edge right through the solid model, and you can do that and pick you know, multiple edges if you can predict where they are and do that. Now, the way to be able to have that feature, and I need to show you because it's not on by default, is under Tools Options. If you go down to the Display Selection area, here you have this area called Selection of Hidden Edges. If you turn on Allow Selection in HLR through Shaded Modes, you get the ability to do that. So just know that you need to check mark that in your options, in your system options, and it'll be saved with your session. You can get back to that and use it. And that's select through hidden edges. Getting towards the end of our presentation here, and just want to quickly wrap up on a few more things. So let's again talk about Instant 3D. I think Instant 3D oftentimes is not looked at favorably because it's viewed as an expensive option to have on. It really isn't. It doesn't really contribute to the rebuild time or display if you have a good graphics card. But it can be very handy to have in using it intermittently along with your more traditional modeling type of techniques. So with Instant 3D on here, I have this base where I need to grow its height, and if I click on it, without editing into or edit definition of the feature, I can actually just start pulling on handles to increase its depth and its height, and you have a ruler also to give you more precise increments for that. So that's what I'm doing here by just pulling on these little blobs and increasing the height. Now, that's great in one aspect of Instant 3D that helps me be very quick when I'm doing modeling and also modifying my model. But also, it's also something that I find is indispensable when actually making adjustments, because it's the only way to do it. In the case of this area here, I want this edge actually to grow out to this edge here, and it's really hard to do that in Sketch. So if I just go ahead and grow this out, let's just go into Sketch mode and do that, and then use my thumb wheel, holding down my Alt key to get a finer increment. Here I can actually just move and preview at the same time. While I make sketch changes, I can actually preview my model to get that very close to that back edge. And that's where Instant 3D becomes very handy. And you really should realize that it's a great helper, even when doing precise type of modeling where you can't normally visualize it without having that preview. And so to our last of the 14 tips and tricks that are my favorites is talking about sometimes when we get filleting, and we all know that when we fillet, we start with the major or largest fillets first and then work down to the nominal fillets. But there are situations, and you might have run across this, where we can fillet it in the proper order, but we always get this at the end, get backed into a corner where we get this edge that kind of fades out, and it's not a very aesthetically nice solution. It's also in injection molding causes a little bit of a flow problem there, or can. So what can we do about that? There is a way to take care of this, but the traditional fillet isn't able to really solve this, because it's not the kind of smoothness that we want this intersection to be can't happen with fillet. And some of you might be wondering, what about setback? Well, setback won't work here either. So let's just cut this model in half, just work on this one half and show you how you can do this. So if we go into our top plane, looking down on the model, we're going to create a little split line. So a split line is, you can create it a number of ways. Here I'm just going to draw a simple circle and then go to my Insert Curve Split Line. And using this sketch, it's going to split these faces. And I'm going to pick all of these interior faces in its normal default projection. And now you can see I have a split face here that then I can use my delete feature again on my S key in a different mode, and that mode is delete and fill. So first of all, let's pick all these interior faces, and then using the delete and fill with the tangent option, I'm going to actually make a patch that's going to be a smooth transition between all those fillets. And so if I turn off my edge view, you can see now I get a very nice, type of transition between all those fillets, and that's really the kind of intent that I want in that particular situation. Okay, so that wraps it up for the 14 tips and tricks. Again, I'm going to post this and have the files available for you. You can practice all of these if you want, but these are some of my favorite shortcuts to SolidWorks. I hope they are for you too. So thanks for listening.